Okay, in this video we are looking at how to write the quadratic equation in vertex form. So let's just start with what our vertex form is. So in our vertex form, I'm going to have y equals a x minus h plus k. So remember that h and k, h comma k, is my vertex. Okay, and x and y are my input and output. And my a value is really the value that we're going to have to be looking for. It's whatever my function is being multiplied by. So in my graph, I can't just look at my graph and determine my a value, but I can determine my vertex. So let's start with our vertex. Our vertex is 1 and negative 4. This would be a minimum value because it's the lowest point in my graph. So since it's a minimum value and my parabola is opening upwards, what that tells me is my a value is going to be positive because it's opening upwards. Another point on my graph is what we're going to need. So let's just find another point. It can be any point. So really the easiest point is to grab like your y-intercept or one of your x-intercepts. I choose to take my y-intercept. So 0 and negative 3. Okay, and now we can actually write this in my vertex form. So vertex form is a lot like your point slope form. So I am taking away from my x value here. So this here, just remember this is in my formula for it to be negative. So my vertex doesn't have to be negative for that to be there. So we're just going to utilize that formula straight as it tells me. So and then I'm going to utilize the other information I have to find my a value. My goal is to find the a value and then write it as a function. Okay, so I'm going to take my other point and plug in. So I have negative 3 equals, I don't know my a value, that's what I'm going to be looking for. And then I'm going to plug in 0, my x value that I know. And then I'm going to plug in my vertex to h and k. So minus is part of my formula. 1 is my x value for my vertex. And then negative 4. So this is going to be a minus 4. Okay, and now I need to, oh, I'm sorry, I forgot a very crucial point. That needs to be squared because it is a quadratic function. Okay, so now I'm going to go through my vertex form. I have negative 3 equals 0 minus 1 is negative 1. Negative 1 squared. So I'm going to go ahead and just write all of this out so we can see it. Negative 1 squared times a minus 4. Well, negative 1 squared will be positive 1. So I'll have negative 3 equals a minus 4. And now I'm going to add 4 on both sides to solve for my a value. So a is 1. Okay, so now I'm going to actually use my vertex form to write my equation. So I keep y just like any other function. So I don't need to put my input and output into my equation now. So y, my a value is 1, so I don't need to write a 1 here, but I'm going to. So we can see it. X minus my vertex 1 minus 4. And then again, we can write it as y equals, oops, sorry, again, I forgot the squared, x minus 1 squared minus 4. You can see it's very easy to forget about the squaring piece, so try not to forget that. That's what makes it a quadratic function. So that's really important. Okay, so let's look at another example. So again, I need my vertex, okay, and my vertex here happens to be 0, 1. And I easily could see that was my vertex because that is where like my symmetry begins. On each side of that I have like symmetry, that my y values are repeating themselves. So my vertex is 0 and 1. Now 1 is my max value, it's maximum. Because every other value here is less than 1. So this is a maximum. And if I think about what that means if I have a maximum, that my parabola is opening downwards. So now that tells me that my a value is going to be negative. Okay, so I need any other point. This time I can't choose my y-intercepts. I have to choose something else. So I might choose 1 and negative 2. Any point works though, but I'm just choosing 1 and negative 2. Okay, so I'm going to start with my vertex form. So my vertex form is y equals a x minus h to the second power plus k. So plugging in what I know, I'm going to plug in my other point here in y. So negative 2 is my y value. I don't know my a value. Plugging in 1 for x minus my vertex 0 squared plus 1. Okay, now I'm going to solve for my a. So 1 minus 0 is 1. Okay, so I want 1 squared times a plus 1 equals negative 2. 1 squared is just 1, so I have a plus 1 equals negative 2. Subtracting 1 on both sides, negative 3 equals a. So my a value is negative 3, which confirms I have a negative value because I have a maximum. So now I'm going to go back and write it in vertex form. Y equals, my a value is negative 3, x minus my vertex 0 squared plus 1. Okay, so from a verbal description, write an equation for a quadratic function which has a vertex at negative 3, 5, and another point at negative 1 and 3. So my vertex negative 3 and 5, again, is my h and my k. Okay, so I have negative 3 and 5. I really can't tell if it's a maximum or minimum. I don't really know. So we're going to have to answer that later. I just know that that's my vertex. I could think about, well, if I have another point, is this point below that point or above that point? I'm really focusing on my y value. So 3 is below 5. So since it's below my vertex, that means I must have a maximum. So then another point, they gave it to me, so I have negative 1 and 3. Okay, so I'm going to use my vertex form, y equals a, x minus h squared plus k. Plugging in my extra point, 3 equals a, negative 1 minus my vertex. So minus negative 3, so that would turn into plus 3 squared plus 5. Okay, so starting to simplify, 3 plus negative 1 is 2, but I have 2 squared times a plus 5 equals 3. So I have 4a plus 5 equals 3. And now subtracting 5 on both sides. Negative 2 equals 4a. And divide by 4. A is negative half. Okay, so I have my a value now, and now I just need to write it in vertex form. Y equals negative half times x plus 3, because it's minus negative 3, squared plus 5.